In this work, we propose a novel pseudo-haptic technique called pseudo-haptic resistance, allowing designers to provide resistance for rotating knobs without the need of bulky and expensive actuators. We create pseudo-haptic resistance by visually slowing down users' real-world rotations of the knob. This can be achieved by changing the control display ratio. As a result, a user's real hand needs to rotate further to reach the target, covering more distance. To study our technique, we build a physical proxy knob, acting as a stand-in for various virtual knobs. We run a 3-stage psychophysical experiment with 20 participants. First, we investigated how much discrepancy between the physical proxy and the virtual object can be used while remaining unnoticed. To do so, we used an adaptive interleaved staircase procedure to determine conservative detection thresholds. We studied 2 different types of knobs, one with visual and haptic marks, leading to higher visio-haptic integration, and another one without visual and haptic marks. Here, we found that we can introduce substantial offsets that remain unnoticeable for users, regardless of the knob type. In stage 2, we determined the just noticeable difference in resistance caused by changing the CD ratio, using a 2-interval forced choice method. We found that we can change the perceived resistance by decreasing the CD ratio, while staying within the unnoticeable range of CD ratio manipulations. Finally, we studied the relationship between CD ratios and physical resistance, developing a model for pseudo-haptic resistance. Here, we used a method of adjustments, asking participants to adjust the physical resistance of the proxy knob until it matched the applied CD ratio. Our results show a clear relationship between CD ratio and physical resistance. Thus, we provide a model for rotational pseudo-haptic resistance that was obtained using forced fusion. We demonstrate a remapped interface inside a VR DJ experience, where we use an on-the-fly hand retargeting technique to allow the proxy to act as a stand-in for multiple virtual objects, which differ in their limits and haptic feedback. Further, we 3D printed different proxies to illustrate how our pseudo-haptic resistance technique can be applied beyond knobs using our forced fusion model, a door handle providing different levels of resistance when using it, and a steering wheel to illustrate bimanual pseudo-haptic resistance. Our work demonstrates that unnoticeable changes in CD ratio translate to physical resistance, and we outline how designers can apply this novel effect to new and existing VR experiences.